we say a set of vectors is linearly dependent. And we talked about this at the very end of class last time, right? Yeah, I should be a set of vectors. Let's call this set A1, A2, all the way down to AN. How big has a set of vectors been so far? It's been in Rm. So this is a set of n vectors, each of which is size m by 1. And we call that set linearly dependent if and only if what is true. We can write one vector, and let's call it, for sake of argument, a sub j, with 1 less than or equal to j less than or equal to n, as a linear combination of our other vectors. What would that mean immediately? If I can write one vector in terms of my other vectors, what would that mean? Linearly, I mean? Yeah, there exists some set of scalars, x1 times a1 plus all the way to the one right before j. Then I go to the one right after j. Then I go all the way down to. And then we can use this really creative use of summation notation where we run through all elements. What was the one thing that we said though? If a sub j is linearly dependent on all the other vectors, then there would exist some scalars x sub k for all the vectors not equal to j. So then we have just this one condition that k cannot be j, right? For some set of scalars. And we had a really beautiful example of that last time, right? And we're going to do that one again, just so that we can be really, really clear on it. Let's analyze this set of vectors from this standpoint. But before we do, let's really cement this. What was the context of that linear dependence definition of this one over here? Let's think about it. Linear dependence is what you might call a compound adjective. It's two words that describe a vector. So this linear dependent or linearly dependent vector, what did it describe? How many vectors did it describe? One. Underneath that vector was also another. Can you claim that B is linearly dependent without the information A1, A2, AN? The moment that I use the concept of linear dependence to describe a single vector, what immediately must I know? You must have a set of vectors. That must be given. Otherwise, it makes no sense, right? The whole idea of linear dependence for a single vector is the vector that I'm looking at can be written as a linear combination of another set of vectors. Okay, so what is this whole linear dependence? What does it depend on? Set of vectors, what does it describe? A single vector. And the whole idea there was if a vector B is linear dependent on another set of vectors, what does that mean immediately? I can create B by taking some certain scalars times the original set that I started with. So formally speaking, there's no new information in B that's not contained in my other vectors, at least linearly. As long as I produce the set of scalars x1 to xn, I can produce B any day of the week, right? Let's go back over to this definition of linear dependence because it's a different definition and it's solving a different problem. What does this concept of linearly dependent describe? Does it describe a single vector? Describes a set of vectors. Does this have anything to do with B right now? No. There's no concept of some other vectors with respect to the original set. It's a property of the original set itself. What's the property say? At least one of the vectors contains redundant information with respect to linear operations. What's the canonical linear operation that exists in this class? Linear combination. What's a linear combination? Scalar vector multiplication and vector addition. What does it mean for a set of vectors to be linearly dependent? One of those can be written as linear combination of the other one.